Hello everyone and welcome. Today I would like to talk about search in rotated sorted array. This question requires you to have a deep understanding of the binary search algorithm. Also, you need to have a good command of the pointer in array. So it's an interesting twist to the original binary search algorithm, and let's get started. Specifically, this question provides you a nonce array, which is already sorted in ascending order. It asks you to return the index of target, but you must write an algorithm with O log n runtime complexity, which means the binary search algorithm. However, the nonce array has already been rotated in a counterclockwise manner with an unknown k steps. So how can you find the index of the target while using the binary search algorithm in this situation? If you are familiar with the binary search algorithm, you know that it relies on a mono order for search range reduction. Fortunately, after counterclockwise rotation, one of the two blocks, as divided by mid, must be in a mono order, specifically when k is less than or equal to mid. After counterclockwise rotation, the first block here, before mid, is in ascending mono order. The second condition is when k is larger than or equal to mid. After counterclockwise rotation, the second block here after mid is in ascending mono order. Thus, first of all, we need to identify which condition it is. As you can see here, if nonce left is less than or equal to nonce mid, then we know it's condition 1. On the other hand, if nonce mid is less than or equal to nonce right, then we know it's the condition 2. You can also see that except for k equals to mid, these two conditions are mutually exclusive. After we identify the condition, we can then leverage the mono-order sign to decide how to move left or right in a binary search algorithm. Specifically, in condition 1, if target is between nonce left and nonce mid, which is a mono order here, then we are pretty sure the index for the target must be in this range. Then we can reduce the search range by moving right equals to mid minus 1. If this condition is not true, then we know the index for the target must be on the other side of mid. In this situation, we will move left equals to mid plus 1. Note that we cannot just compare target versus nonce mid because target can be larger or smaller than nonce mid. Although the index for target is on the right-hand side of mid. Similarly, in condition 2, if target is in between nonce mid and nonce right, then we are sure that the index for the target must be on the right-hand side of mid. Then we can move left to be mid plus 1 to reduce the search range. On the other hand, we will move right to mid minus 1 to reduce the search range, and the index for the target is on the left-hand side of mid. Again, we cannot just compare target versus nonce mid, because even if the index for the target is on the left-hand side of mid, target can be larger than nonce mid, or it can be smaller than nonce mid. There's no telling of this since this order here is not a mono order. With the background introduced, now let's write the code. So first of all, we're going to initialize left and right pointed to the first and last item in the nums array. They are the 2 pointers. And then we will have the mid as left plus right and divided by 2 by the floor division here to make sure mid is an integer. And we do this while left is less or equal to right. Okay. And finally, if we cannot find the target, then we will return -1. Okay. So in this process, we want to see if nums mid equal to target or not. If it is, we simply return mid. If not, we want to know which condition it is. So if nums left is less than or equal to nums mid, then this is our condition 1. Okay, when k is less than or equal to mid. In this condition, we want to test if target is between nums mid and nums left. Okay, and this is the Monod order here. Okay, so if this is true, then we will move right to mid -1. Otherwise, we will move left to mid +1 here. And we will note that the block between nums left and nums mid is in ascending Monod order. Otherwise, we will test the other condition. So condition 2, and which is mutually exclusive. So when k is larger than mid here, condition 2. Okay, in this condition, we want to know if target is between nums mid and nums right. Okay, and target. And the reason is because the block between nums mid and nums right is in ascending Monod order here. And if that's true, then we want to move left to be mid +1. Otherwise, right will be mid -1. And that's our code for this question. Now let's test this code to see how it works. We submit, pending, and done. So let's see. It passed the test. It's pretty good. Finally, we can analyze the code for complexity. So because we use binary search algorithm here, so the time complexity is O log n. And as for space complexity, we only use constant space variable here, like left, right, and mid. So it will be O1 for space complexity, constant space variables. Okay. Okay, so that's all for this video. I hope you find this video to be useful. Please feel free to subscribe for more videos, and I hope to see you next time soon. Goodbye.